Hi guys, this is O-Level Chemistry, paper 12, June 2021, question 1. The formula of magnesium oxide can be investigated by using the fact that when magnesium is heated, it reacts with oxygen to form magnesium oxide. Which apparatus is used for this investigation? Okay, we are heating magnesium oxide. No, we are heating magnesium to obtain magnesium oxide. So it is reacting with oxygen in air. So, which piece of apparatus is used for this investigation? The apparatus in one is for the collection of a gas. Here, no gas is being collected. So, this apparatus is not useful for our investigation. Two is a weighing balance. A weighing balance would measure the increase in the mass of the solid because when magnesium reacts with oxygen, oxide ions are added to the magnesium metal forming a salt and there is an increase in mass. So a weighing balance is required and a crucible over a tripod stand is also required because the heating will be done when magnesium will be placed in the crucible. So 2 and 3 are pieces of apparatus that are essential for our investigation, whereas 1 is not because there is no collection of gas involved. So this makes option D the correct option for our question. Question 2. Which property of a liquid ester can be used to check its purity before use as a food flavoring? So, in order to check the purity of a compound, there are four options given here: the boiling point, the color, the smell, and the solubility in water. Out of these four, boiling point will be the correct answer because a pure liquid has a fixed boiling and melting point. If there is any impurities present, then the boiling and the melting point would vary. So if the ester is pure, its boiling point would be the boiling point that is already known. So it will have a fixed boiling point. So boiling point is correct. Color depends on if there is coloration added to the ester, which results in an impurity being present. So a color of a substance is not an indication for its purity. Neither is its smell and solubility in water. Now, the solubility in water for different compound or different series of compounds is different, and the solubility is also dependent on the mass. The lower the mass, the greater the solubility, the higher the mass, the lesser the solubility. So, this is not accounting for the purity of the substance. So, option A is the correct option for this question. Question 3. Which separation method would give pure samples of both substances from the mixture? Okay, A. Copper sulfate crystals and water. Now, copper sulfate is dissolved in water. So, in order to obtain this, we would evaporate the solution and then crystallize it to obtain crystals of copper sulfate. But those crystals will still contain water of crystallization. So, the method written here does not remove water completely. Whereas, if we distill off the water, then copper sulfate will be left behind as a solid. So, this method is less accurate than distillation. Next, ethanol and water. Ethanol and water are both polar substances. They will dissolve in each other. So, in order to separate them, we would use the process of fractional distillation. Evaporation will result in both of them evaporating. Next is salt and sand. Salt and sand are both solids. Solids cannot be separated by filtration. And D, nitrogen and oxygen, both are gases. Both can be liquefied and then separated using the process of fractional distillation. So, option D is the correct option for this question. Question 4. An aqueous solution of J is a colorless solution that contains cations and chloride ions. Separate samples of the solution give a white precipitate with a few drops of aqueous sodium hydroxide and with a few drops of aqueous ammonia. So this actually tells us that we have Al3 positive or Zn2 positive or Mg2 positive or Ca2 positive present. In fact, with ammonia, calcium will not form ions. It will only form ions with sodium hydroxide. So calcium can be eliminated, but the rest of the three are definitely present. So which statement about J is correct? The cation in J must be Al3 positive. No, we have a choice. It could be either of these three: aluminium, zinc, or magnesium. The cation in J must be Fe2 plus. There is no green color in the precipitate involved, so it is not Fe2 plus. When dilute nitric acid and barium nitrate are added to an aqueous solution of J, a white precipitate is formed. This will only happen if sulfates are present, and they have clearly stated that chlorides are present. So next, when dilute nitric acid and aqueous silver nitrate are added to an aqueous solution of J, a white precipitate forms. Yes, this white precipitate is that of AgCl solid that has formed, silver chloride. And this is a test for the halide ions, of which the chloride ions would give a white precipitate. So option D is the correct option for this question. Question 5. Gas X has the following properties. It is colorless, no effect on either damp, red, or blue litmus, no effect on lime water, and is flammable. Okay. Colorless except for chlorine gas, all other gases that we test for are colorless. So it is not chlorine. So we can eliminate chlorine from the options. No effect on either damp, red, or blue litmus. So it is neither acidic nor basic. So out of the remaining options, we have ammonia, and ammonia turns damp, red, litmus blue because it is basic in nature. So ammonia has been eliminated. It has no effect on lime water, so it cannot be carbon dioxide gas, but carbon dioxide is not one of the options given. Now the fourth one, it is flammable. Now between hydrogen and oxygen, hydrogen is a flammable gas and oxygen is not a flammable gas. So if you use a glowing splint and hydrogen is exposed, you get a pop sound. That pop sound is basically hydrogen burning in the presence of oxygen. And if oxygen is present, it relights a glowing splint. It does not give a pop sound, so it does not burn. So based on this, the correct option for this question is option C. Question 6. Which statement about states of matter is correct? When a liquid freezes, it becomes a solid. Yes. And energy is released to the surrounding. Yes. Freezing gives off energy. This is correct. Next, when a liquid reaches its boiling point, it becomes a gas. Yes. This process is called evaporation. When a liquid reaches its boiling point, it turns to a gas. Yes, this process is called boiling, not evaporation. In evaporation, there is no change of temperature. C. When a solid changes directly to a gas, the process is called condensation. When a solid changes directly to gas, it is called sublimation, not condensation. D. When a solid melts, the particles get further apart and have less energy. When a solid melts, the particles do get further apart, but melting is due to increase in temperature, and increase in temperature results in a gain of energy. So they would have more energy, not less energy. So based on this, option A is the correct option for this question. Question 7. Use a periodic table to answer this question. Okay. Which two particles have the same number of electrons? So argon has a proton number of 18, calcium has a proton number of 20. The proton number is equal to number of electrons, so this is different. Next, sodium. Sodium has a proton number of 11 and a charge of +1. So 11 minus 1 is 10. Potassium has a proton number of 19 and positive 1 charge, so 19 minus 1, 18. These are also different. Next, Fe2 plus is the ion of iron, which has a proton number of 26. So 26 minus 2 is 24. And Fe3 plus is also an ion of iron. Iron has a proton number of 26. 26 minus 3 is 23. So these are also different. Now, the next one, calcium. Calcium has a proton number of 20 and a charge of +2. So 20 minus 2 is 18. And scandium has a proton number of 21, and 21 minus 3, which is its charge, is equal to 18. So here, calcium 2 positive and scandium 3 positive ions have the same number of electrons present, making option D the correct option for this question. Question 8. The table shows data of particles W, X, Y, and Z. It shows its proton number, nucleon number, and number of electrons. Okay. Which statements are correct? W and X are isotopes of the same element. So now isotopes of the same element have the same number of electrons and protons, but different number of neutrons. So W and X have the same number of electrons and the same number of protons as shown in the table. But the nucleon number is 12 and 14. So if we subtract 6 from each, because both of them have the same proton number, we end up with the neutron number of 6 for W and 8 for X. So it has a different number of neutrons. So statement 1 is correct. W and X are isotopes of each other. Next, Y is in group 5 of the periodic table. If it is in group 5 of the periodic table, we look at the periodic table, and in group 5 we have nitrogen that has a proton number of 7 and a nucleon number of 14, and nitrogen belongs to group 5. So statement 2 is also correct. Z is a cation. In order for Z to be a cation, its number of electrons must be lesser than its number of protons, whereas in the case of Z, number of electrons is greater than the number of protons. So if the number of electrons is greater, Z is an anion and not a cation. So statement 3 becomes incorrect. This makes option A the correct option for this question. Question 9. Which dot and cross diagram correctly shows the molecule of ethene? Now, ethene is an alkane. So we have a carbon-carbon double bond present with each carbon atom covalently bonded to two hydrogen atoms. So there are two hydrogen and on each carbon, which makes four hydrogen atoms in the molecule along with two carbon atoms. Structures C and D have six hydrogen atoms present. So structures C and D are wrong. They are not ethane. A and B have four hydrogen and two carbon atoms. So now we look at the number of bonds present. In A, there is a single bond present between the two carbon atoms, but the electrons shared are from the same carbon atom. It should have been a dot and cross, but still the second bond is missing. So based on this, option A is eliminated. Now option B remains. Option B is the correct option. Now let's look at the bonding. So a single bond between each carbon and hydrogen atom with the dot and cross shown, and two dot and cross for carbon-carbon, showing a double bond present. So this makes option B the correct option for this question. Question 10. The names and formula of three nitrogen compounds are shown: ammonia, hydrazine, and hydroxylamine. Which compound has the highest relative molecular mass, and in which compound is the percentage by mass of hydrogen the greatest? Okay, so first we calculate the MR. So for ammonia, it's nitrogen, which is 14 plus 3, 17. Its MR is 17. For hydrazine, it's 14 in 14 into 2 is 28, and plus 4 is 32. So its MR is 32. And for hydroxyl, I mean, the MR would be nitrogen 14 plus 3 hydrogen 17 plus 1 oxygen 16. So 17 plus 16 is 33. So the highest MR is that of hydroxyl amine. So option C or D might be correct. A and B have been eliminated. Now we find out the greatest percentage by mass of hydrogen. So the two options are either ammonia or hydrazine. So we calculate the percentage by mass of hydrogen. In ammonia, we've got 3 atoms of hydrogen. So 3 upon its MR, which is 17 into 100. This gives us a percentage of 17.65%. Whereas for N2H4 hydrazine, we've got 4 hydrogen atoms. This would be 4 upon its MR, which is 32 into 100. This gives us a percentage value of 12.50%. So the greater percentage is that of hydrogen in ammonia and not of hydrogen in hydrazine. So this makes option C the correct option for this question.